we're going to go over is a object sliding down a ramp. So I'm going to draw this kind of big because it's not going to be particularly accurate because I'm trying to do it on here. You guys are going to need to know here. Alright, so we have a ramp. It's going to be at some angle, call it theta. We have, let's say, a box. Alright, there is friction on the ramp. Forces are acting on this box as it slides down the ramp. Gravity. Normal force is going to be out. This is not a problem, this is just a general diagram. Yes. Is in red because FG gets broken into two components. We're going to call this Fy, Fx, and this angle is also FG is right there. Yep. Fy and Fx from FG in the angle. Okay. So for this example here, force is going to be going up or down the ramp is going to be force of friction. Does that make sense? So force X is what's that way. So force X is pulling it down the ramp. Force of friction is holding it back. Fy and Fx pulling it down the ramp. Fy is the component of gravity that's pulling it into the Fy is part of gravity.
So Fx is friction, Fy is gravity.
Ramp. It's not. It doesn't have anything to do with friction necessarily.
Fx is going against gravity. Or with gravity.
Yes. So like part of gravity pulls it into the ramp. Part of gravity. Does that make sense?
What's the difference between
So that's just the direction of gravity against the
Yes. Yep. The ramp. So if you're standing on like a ramp, gravity, part of gravity. And what do you think Fy is going to be equal to? Fy. I did give it away. So, are equal and opposite. So I'm going to do and Fy to do that. Does that diagram? No. Right, what part don't you? Yep. Fy, so Fy, you're breaking up because we want to kind of have it so that it's either parallel or perpendicular to the ramp for both of them. Y is the portion of gravity that's pulling the box into the ramp. X is the portion of gravity that's pulling it, making it go down the ramp.
gravity pulling or pushing down the ramp.
Pulling down the ramp would be better.
Gravity pull.
The next kind of diagram that's good to have seen before is like a box being pulled along level surface. If you're pulling up on the wagon, you're pulling at an angle. So we've got a box and a force acting. So we're going to call that the pulling force, and there is friction here. So what other forces are going to be acting on this box? Yep. Yep. What? Friction. And for reasons that I'll explain in a second, I'm going to draw normal force a little shorter than gravity. And I'm going to do red, since it's at an angle of theta, into fx and fy again. It's going to be moving to the right. Alright, so I'm going to do something that makes it a little easier. If you look at all forces in y direction, in the y direction. What? F of y, f of g, and f of n. And down negative as I write these out, because so we're going to say fy plus fn minus fg. And what do those have to add up to equal? 0. Alright, so what that means is our normal force is going to equal Fg. That makes sense? So normally, the normal force we had was just Fg, but now we're lifting it up. We're going to have to take something away from the normal force, because part of the normal force is being done for it by that lifting up force. Does that make sense to everybody? If your computer is sitting on the table, the table applies normal force. If you lift up a little bit on the computer, that normal force goes down. That makes sense? T equation going to be for this. The total force, remember, all we matter for the total force is just where it could be moving. Yep, Fx minus force friction. So those are kind of the basis we'll be working off for these problems. Does that make sense? It'll be a 23 kilogram box is sliding down a ramp that makes an angle of 29 degrees. The coefficient of friction between the ramp and the box, the acceleration of the box down the ramp. Alright, I'm going to draw our diagram. We'll draw it in red. Fx, Fy, maybe that's what we'll do tomorrow. Yeah, I'll think. Lab. Alright. That's our diagram. So the first thing we want to write down here is our Ft equation. What's our Ft equation going to be? Yep. That makes sense, everybody? Yeah, oh, sorry. Like, it's still the same triangle. Like, this is still 29 degrees. It does, that's the same as if I drew it like, that. Sorry about that, I didn't mean to do that. Alright, so now we substitute in to this equation, so we say Ft equals ma. What's Fx going to equal? We want to use Fg is the hypotenuse, so we want to use that. Yep, so it's going to be sine times Fg. Does everybody understand how we got to that?
Yeah, but where did you get that line?
What?
Next to gravity. Yeah, but the line.
That line right there is
Next to it, the line next to that.
This? That's just a perpendicular line. That's Fy. That's the force of gravity that's pulling it into the ramp. Right. And minus, what's our equation for force of friction? Mu times what? Normal force. So MA equals sine 29.
Oh wait,
Mass times gravity minus mu. What can we substitute in for Fn? I'm going to write one more time out here so you guys can kind of see how this works. MA equals sine 29. What does Fy equal? 29 times what? And we're going to do one more substitution before I put numbers in so you guys can just see how this works. So sine 29 mg minus mu. What's Fg going to equal? Mg. So what happens to the mass in this? So the masses are all canceled. So the mass of the box doesn't matter for it sliding down the ramp. So now let's find A. So we say A equals sine times 9.8 minus 0.19 times cosine 29.8. And what's A end up equaling? Equals, oops, 3.12 meters per second squared. Any questions on that? Did everybody get 3.12?
what is cosine? Whoa, no.
Number 2, a force of 53 newtons applied at an angle along flat ground. What is the coefficient? The coefficient of friction is 0.11. What is the acceleration of the box? So this time, you gotta read some of these carefully. It's a ramp, but if obviously it's being pulled along flat ground here, so it's being pulled like that. It's FP. We're gonna find Fy. We've got Fg. Fn. Is Fn equal to Fg in this one? Nope. Alright. But again, we're going to start with our being lifted up off the ground a little bit. That's force of friction.
Wait, what's that?
Fp is the pulling force. Fx is the horizontal component of the pulling force.
And that's going to the right.
That's going to the right.
And FX is
Going to be. Yep, Fx minus Ff. Alright, so Ft equals Ma. What is Fx going to equal? And this should be, yep, cosine 26 times Fp. Center that came from. Right, and Ff equals mu Fn still. Mu. So we got Ma 26.
How come last time with FX we used sine?
It's a different diagram. So this is the. Yeah, if you look at the triangle. Right, minus mu. What's Fn equal to in this one? Fg minus Fy.
Yeah. Is that always going to be the case?
Almost always down or something like that, like a stroller type thing, then it would be different. But we'll talk about that later on. For now, just
So for these types of problems,
alright. So we'll go MA equals cosine 26 FP minus mu mg, and what's Fy going to equal? Sine 26 times what? FP. Right, any questions on that step? So now we have all those out in this case. So it's going to be 8 kilograms times A equals cosine 26 times 53 minus mu, which is 0.11, times 9.8 minus sine 26 times that's a parentheses. So like there's a parentheses there and there. 8's the mass. So A equals 5.2 meters per second squared. Number 3. A rope attached to an engine pulls a 240 Newton crate up a 17.6 degree ramp at constant speed. The coefficient of friction is 0.1 or 0.31. What is the magnitude of the force that the rope exerts on the crane parallel to the ramp? Alright, so what we've got here is we have a box, and it's attached to, let me just draw like a motor up here. It's attached to time. Does that make sense? So there's going to be a pulling force up the ramp, and that's what we're looking for. Alright, so we still have gravity pulling down. We have Fx still goes down the ramp. What direction is force of friction going to be going this time? Ramp. F of x is going down. So force of friction is going down, and then we have normal force going up like that. And these two angles are still equal. Alright. What we're going to do actually is it gives us the weight. A lot. If you're ever given the weight, I would strongly suggest find the mass right away, just because otherwise you're going to need it later. Fg is the weight equals mg, so 240 newtons equals mass times 9.8. 24.5. Alright, so that's just a good idea. If it says the crate is 240 newtons, get that in kilograms right away. It'll just make your life easier. Alright, so now, equation. Box is moving up the ramp, so what force is pulling the box? Alright, what are we going to do with force of friction? Subtract it. And what are we going to do with the x force? Subtract it. So we've got force of friction is pulling it down the ramp. Force of friction is always against the motion. And force of X is also pulling it down the ramp because it's in the opposite direction. That's what we're going to solve for that portion of force of gravity that's pulling it down the ramp. And remember, Fy is the portion of gravity that's pulling it into the ramp.
Then why don't we add the force of gravity?
We usually just solve, you use gravity to solve for Fx and Fy. In the previous problem, it was a different diagram, so it kind of had very little to do. All right. Any other questions?
I just have a question. How do you know which way f of x is going?
F of X always, on a ramp, it always goes down the ramp. Something up the ramp. Any other questions on this part? Alright, so now we just start substituting stuff in. So we say Ft. Fp is what we're looking for, so we'll just leave that there. Minus mu Fn minus Fx, and what's Fx going to equal? Times Fg. So we'll say Ma equals. What's Fn going to equal? Fy minus sine 17.6 mg. So Ma equals pulling force minus mu. What's Fy equal? 0.6 times what? Fg, but we'll just put it in as mg to save ourselves some time. 17.6 times mg. So I substitute in what we know. So 24.5. What's a? Since it's constant speed, 0 equals Fp minus mu 1 times cosine 17.6 times 24.5 times 9.8 17.6 times 24.5 times 9.8. And what does Fp equal? The answer is 143.5 newtons. Do it, you're going to end up bringing this over to this side and this over to that side, and so you end up adding this and this together. You probably subtracted them and forgot that negative sign right there. Make sure you include the 24 9.8. Alright. Any questions on that one? Alright, so last one here. So, find the acceleration of the boxes. So we're still going to have Fg goes down, Fy, if the boxes are so alright. Moving that way, so which way friction is friction going? Opposite. So down. So that's force friction. And we've got normal force up like that. With our Ft equation, what is our FT equation going to equal? If it's moving, which way is it moving? To the left. Yes. What force is going to be pulling it to the left? Yep. The force of gravity on M1. So we're going to say Fg of 1 minus FF. What else? Here, I'll pause it. So this equation right here. So like we said, it's moving up the ramp and to the left. Does that make sense?
Yes.
So the force is moving up it. Does that make sense? So that force is going to be Fg1. So that's where this part came from. That's because the force of friction is always going to be opposite the motion. So that's going down the ramp. So we're going to subtract that. So that's force of friction on 2. And because 2 is the only one with friction on it. Yep. It's down the ramp. So we're going to subtract that one as well.
Why does that one need it too?
Because it's the, well, it's FX. It's FX.
But like, isn't there only one FX? So
There's only one FX, but there could be more FXs, so it's good to label them. If there was like another ramp over here. Right. So any questions on this equation? Everybody okay with that? Could everybody, do you feel like you could come up with something?
I mean, yeah, I guess the part that I would have gone was the negative
FX, so that's why it's important to draw it. Going on. And you subtract everything in one direction and everything else in the other direction is positive. Okay. Alright. So now we're going to substitute in, and I'm going to substitute in a little. You guys are fairly competent at that. So MA is FT. What's FG1 going to be? MG. Mu. We'll say. Well, do you want me to substitute it the whole way? So mu Fn minus, what's Fx2 going to be?
sine 32 G. Is that it?
Yep. And I'm going to actually label this as, yeah, we'll do it in a second. What? And this is M2 and this is M1. Alright, what is to do? What is this M going to be right here? Total. So it's going to be M1 plus M2 times A equals M1 times G Fy minus sine 32 times M2 times G. And M1 plus M2 times A equals M1 times G minus mu. What does Fy equal? Cosine of 32 times minus sine 32 M2 times G. And what M is this right here? 2. So now we'll just plug our numbers in. And we get 8.5. I don't want to do that. 8.5 times A equals 8.5 times 9.8 minus 0.29 32 times 4.5 times 9.8 minus sine times 4.5 times 9.8. Called it 3.95 to make Alyssa happy. All right. Main thing I want. Okay. Main thing I want you guys to. Does everybody feel like if you have this, you can get through it? This equation is kind of tricky sometimes.
The equation is given.
If this was given, you could do it?
Yes.
Okay, we can work with that.